A line creates a triangle with an area of 50 over square root of 3 square units when it intersects the coordinate axis. Determine the equation of this line given that a perpendicular drawn from the origin to the line forms an angle of 30 degrees with the x-axis. Okay, let us begin. First, what we'll do, we'll try to understand the problem graphically. So here we have the coordinate plane, the xy coordinate plane, and we have the line L which intersects the x-axis in the positive direction at the point A, and it intersects the y-axis in the positive direction, let's say, at the point B. Now, we also have another line OC. So let's say this is the line OC, which is going to be perpendicular to the line segment AB, or you can say perpendicular to the line L, such that it makes an angle of 30 degrees with the x-axis. Our goal will be to determine the equation of the line L. Okay, so what we'll do, first we'll consider an equation of the line. So let's say the equation of the line is given in its normal form as x times cosine of alpha added to y times sine of the angle alpha, and this is going to be equals to p. So let's say this is the equation of the line. This is the equation of the line L that we need to determine. Now, we need to specify what's the alpha here and p here. So here alpha is the angle made by the perpendicular line OC with the x-axis. Now in that case, that's 30 degrees, and OC, which is the perpendicular length of the line from the origin, that is going to be denoted by p. So let's specify that, where p is going to be OC and we have alpha equals to 30 degrees. Okay, now it's also given in the problem, that means the triangle, we clearly see that the line L is forming a triangle with the coordinate axis, which is the triangle AOB. So it's given in the problem, that is the area of the triangle AOB, which is right angled at O, that's equals to 50 over square root of 3. So that is the area, it's in square units. So this piece of information is given to us. Now, what is the area of the triangle ABC? Now, clearly from figure we can say the area of the triangle AOB. So that's going to be half times the base. So base, that is OA, times the altitude. So that's OB. So we have half times OA times OB. So this is going to be equals to 50 over square root of 3. Okay. Let's do one thing. Let's label this as number 1. We'll come back to this in a moment. Our goal will be to determine the value of OA and OB. So let's do one thing. Let's start by first computing OA. So here what we'll do, we're going to consider the lower triangle OAC. And what we'll do, we are going to take cosine of that angle 30 degrees. So in the lower triangle, we have the triangle ACO, or you can say OCA, which is right angled at C. Here we have the angle AOC, that is going to be equals to 30 degrees. This is given in the problem. Now, when we take cosine of the angle 30 degrees, this is simply going to be the ratio of the adjacent to that of the hypotenuse. So here the adjacent, that's OC, divided by the hypotenuse, which is going to be OA. Now let's use the value of cosine of 30 degrees. So that's square root of 3 over 2 equals to, so we have OC. OC here is denoted by P. So P, that is going to be divided by OA. Okay, so let's do one thing. Let's isolate OA from here. So OA, this is going to be equals to 2 times P divided by square root of 3. Okay, so we're going to label this as number 2. We're going to keep it aside. Next, we are going to consider the upper triangle OCB. So we have the upper half of the triangle OCB, which is right angled at C, and here clearly the angle COB, that must be equals to, so here what we can do, we can take 90 degrees and from here subtract the angle AOC. Now AOC, that's 30 degrees, which means 90 minus 30 is going to be 60 degrees. So here we have angle COB, this particular angle, this is 60 degrees. Fine. So what we'll do, we'll take cosine of that angle. So we'll take cosine of 60 degrees, and the ratio, that is going to be the adjacent, which is OC, divided by the hypotenuse, so that's OB. Now cosine of 60 degrees, that's 1/2. So we have 1/2 equals to OC. So OC, that's going to be P over OB. So Let's cross multiply and isolate OB. So OB is going to be equals to 2 times P. So we're going to label this as number 3. So we have successfully obtained the value of OA and OB. So what we'll do, we're going to equation number 1. So equation number 1 implies we had half times OA times OB. That is the area of the triangle OAB or AOB, you can say. This is going to be, this is given as 50 over square root of 3. Okay, so let's use the value of OA and OB. We have half times OA. The OA is 2P over square root of 3. Multiply to OB, so that's 2 times P. This is going to be equals to 50 over square root of 3. So here we can factor out 2 and 2, and then we can also factor out square root of 3 from the denominator of both sides, and this is going to leave us with 2 times P squared equals to 50. Or we have P squared, that's going to be equals to 25. We can take the square root and we're going to get two values, plus or minus 5. So P comes out to be plus or minus 5. So we have successfully obtained the value of P. So we now have P, we have alpha. Now we are ready to find out the equation of the line. We can say now, or we can say now, equation of the line L, equation of the line L. So that's going to be x times cosine of angle alpha added to y times sine of angle alpha equals to P. So we have x times cosine of 30 degrees added to y times sine of 30 degrees. That is going to be equals to P, which is plus or minus 5. Now cosine of 30 degree, we know that is square root of 3 over 2 added to sine 30 degree, so that's 1/2. This is going to be equals to plus or minus 5. Let's multiply throughout with 2 to get square root of 3 times x added to y equals to, so 2 times 5, that's 10. We're going to get plus or minus 10. So this is going to be the final equation. Thus we can say square root of 3x plus y equals to plus or minus 10 as the required equations. The required equations of the line. So actually there are two lines that we're getting. We are getting square root of 3x plus y equals to plus 10. That is going to be equation 1 of the line. And the other equation is going to be square root of 3x plus y equals to negative 10. So here as we can see in the figure, we have two lines. Both of the two lines are parallel to each other. The yellow line, its equation is going to be square root of 3x plus y equals to positive 10, and the equation of the red line is going to be square root of 3x plus y equals to negative 10. Now in each of the two cases we see that the line which is denoted by the blue color, the OC, that is going to be the perpendicular distance P. So this is going to be positive 5, and if we consider OC prime as the perpendicular distance of the red line from the origin, so that is also going to be 5 units, and so it's in the negative direction, so we can consider it to be negative 5. So that's why we obtain P value to be equals to plus or minus 5. Okay, so these are the two possible equations of the line.